Rising demands and electricity costs, coupled with a global target of reducing emissions worldwide, are creating new requirements for everyday industries.
If you look at countries, our country in particular, cities, counties, states, they're all putting out new, more aggressive energy standards that they're trying to hit. It's hard for a building owner or a business to try to hit these demands in such a short amount of time without potentially hemorrhaging a lot of money. And the reason why they're doing this is that they want to decrease carbon emissions. They want to decrease energy usage, but it's going to take time to accomplish that, to reach those goals. So you need to find ways to take the technology that we have there now and be able to reduce the energy use of it. And it's very important.
With refrigeration and air conditioning being the main energy consumer in buildings today, governments and private businesses are in search of cost-effective, sustainable solutions that will provide immediate results.
HVAC systems use an incredible amount of energy. For a regular building, it's somewhere between 30, 35, and 40% of the energy. For supermarkets, 40 to 60% of the commercial refrigeration. In terms of energy, you can't replace all the equipment, all within those timelines. Producing new equipment creates more carbon. So by able to retrofit older equipment and make it more energy efficient, you're also reducing carbon emissions on that as well.
HVAC systems are designed to handle the load of their systems during the hottest days of the year. However, these systems don't require the full load for the rest of the year, creating the need for a solution to reduce system capacity.
When we design air conditioning systems, refrigeration systems, we always design them for the hottest day of the year. And the hottest day of the year, it could be 1 week, it could be in some places for 2 months. So all the rest, you don't need full capacity. If we manage to reduce that capacity when the demand is not needed, then that's how we can start protecting compressors. When you vary your mass flow on a refrigeration air conditioning system, you can have nearly the same capacity if you have an efficient condenser and an efficient evaporator. So this is where software and the technology comes in.
I worked in a company that was the first company to bring remanufacturing to the United States. Through the years, we always try to build the best compressors. And every time I spoke to anyone, when it came to technical analysis, I always used to ask them, what's the temperature at the compressor on the income and the intake, suction, and then the discharge? And they immediately start to go into superheat and other technical measurements. I would say to them, I want to know the suction and the discharge, and every single time they would give it to me, but not measure it. They would take it off the chart. In other words, if it was X amount of pressure, then it would be this temperature. That's not the way it works.
New technologies are evolving every day to reduce energy consumption. While some play a small role, others are completely revolutionizing energy consumption. However, many of these technologies require carbon-intensive manufacturing processes that counteract the goal of reducing their footprint.
Compressor castings use a lot of CO2 emissions. There's no way around that, but in the compressor industry, when you recycle something, you're saving CO2 emissions. And as of today, it's probably one of the primary sources of energy savings. We actually remanufacture compressors to upgrade them. With the new smart device that Falkonair has developed, that intensifies. It protects the compressor. It allows the compressor to run only in its mass flow design that's under the demand of the system. I think that the more we can remanufacture, the better it is for our planet.
Now, groundbreaking technologies are bridging the gap between existing controls and this technology in an effort to avoid expensive operating and breakdowns.
I've been doing energy conservation work for the last 40 years. Well, Falkonair has developed a technology from the standpoint of I need to know what the compressor's doing so that I can adjust its speed to match the load. And then I put it on a 50 horsepower compressor at one of my customers, which I've been monitoring since 2017, and we're saving almost 50% energy.
The part that really attracted me is the fact that they measure the suction temperature and the discharge temperature physically on the compressor. And the engineer that created it created an algorithm with AI controlled that runs a variable speed that actually turns it into a mass flow speed.
Innovating variable mass flow technology with optimized intelligent compressor control is helping to improve energy efficiency on older HVAC-R systems as a retrofit solution.
Our system has an AI learning behavior. So it looks at the behavior of your compressor, ambient temperatures, looks at the behavior of your mass flow of your refrigeration system, and by gathering all that information, we create an algorithm that maintains your capacity and slows down the compressor when you don't need it.
Made with sustainability in mind, the unique solution is suitable for old or new systems being built today, helping to reduce energy consumption now and into the future.
They call it monitoring-based commissioning, which means I can monitor it, I can adjust it, make it all the ways optimized. So we're controlling the speed of the compressor to match the load. And we're seeing anywhere from 20 to 50% energy savings. That's what blew me away. I've never seen a technology to have such a big impact.
By moving the temperature up and down on the compressor, because of AI, what it actually does is it only allows the compressor to run with mass flow. And they're learning, and we're learning every day, that it actually learns what is required on the demand, and as it learns that, it tweaks the compressor operation.
Energy efficiency came as a byproduct of me thinking, how can I protect compressors? How can we save energy but keep our systems reliable? The technology is not just helping the systems today, it can help systems in the future.